All right, welcome back, everybody, to SAT Math Crash Course Day 1, Part 2. We've got Caden joining us today, and we've got some more questions up here on the screen. And we're still practicing that strategy of plugging in values in place of the variables. It's going to simplify these questions. Caden, go ahead and read question number 14 for me, please.
All right. If 3x minus y equals 12, what is the value of 8x over 2y?
Yeah, so I'd read that 8 to the power of x.
Yeah.
Yeah, 8 to the power of x over 2 to the power of y.
Right.
Okay.
So that's just...
Yeah.
Yeah.
Okay. All right, so it may not look super obvious, but this is a plugging in values in place of the variables question. There's another way to approach it. I'm going to actually go over a couple different ways to approach this question here with you. But let's start by plugging in values in place of the variables, because that's enough to get you the right answer here. Okay. So
Right.
we're going to come up with some values for x and y. We're going to plug them into the expression in the question. Oops,
Okay.
on the erase function. There we go, that expression. And then we're going to see what matches up with the answer choices, or if we can eliminate some of these answer choices. All right, any questions about what we're going to do?
No.
Okay, all right, good. So give me a value for x and y.
So does it matter like any value for this one?
Well, again, that's sort of always the question, right? Like, okay, well, you know, is there a specific set of values I'm limited to, or can I just plug in anything? They give us this expression right here, right? So we can pick anything such that 3x minus y equals 12. And as long as 3x minus y equals 12, we can pick whatever we want.
Okay.
But we're limited by that.
So then we could make x, then that could be like 4.
Yeah, we can make x 4. And what would y have to be?
0 for that.
Yeah, there we go. Okay, great. That's just kind of some basic arithmetic there, right? 3 times 4 is 12. 12 minus 0 is 12. Okay. Any questions about that, or does that make sense?
That makes sense.
Okay. Now you could plug in, a lot of students want to plug in 5 for x. So you can make x 5 and make y 3. That would give you a true statement, and that would work for this question.
Yeah.
You know, you could make x 6, and you could make y, what would that be? 6, and then and y would be 6 as well. You could do that. But again, the smaller values, the better. And the best
Right.
values to plug in really are x is 4 and y equals 0. That is the best. There's no question. Okay?
All right.
All right, so let's plug those values into the expression. And we'll get 8 to the power of 4. Move over here on the whiteboard. We'll get 8 to the power of 4 over 2 to the power of 0. What's anything to the power of 0? I'm guessing you learned this at some point, but you forgot.
You right?
Okay, great. All right, yeah. That's, I guess it's just the standard.
Yeah. It's like
Do you remember or no?
no, I don't think so.
So anything to the power of 0 is 1.
Okay.
Okay. Anything to the power of 0 is 1. Let me explain why, real quick, because I you know, as a student, I remember learning that and being super annoyed because no one could explain to me why anything to the power of 0 was 1. And I remember getting very frustrated with my teachers. They couldn't explain to me. Basically, the answer I got, and this is what I got for a lot of math, right, was like, just know that whenever you see anything to the power of 0, it equals 1. I'm like, okay, all right, well, that's annoying. I don't get it, but I'll do it, whatever. All right, so I remembered it at one point and then forgot it later in life because it never made any sense. All right, so let me show you why. So let's start with, let me give you an expression.
Okay.
Like x to the power of 5 over x to the power of 3, okay?
Okay.
What does that equal?
Uh,
Can we simplify that?
well, we would plug in something for x.
Well, we could do that, yeah. But we could do that. But just dealing with the variables, do you know how to simplify that with the variables or no?
I remember learning it.
Yeah. Let me show you. It's all. I promise you, this is all going to make sense. Think about what it means to raise something to the power of 5. What's that mean?
So like, that would be like multiplying it like that many times.
Yeah, you're multiplying x 5 times, right? So x
Yeah.
power 5 means x times x times x times x times x, right? Over
Right.
x to the power of 3, right? Which is what? What's that equal?
X times x times x.
X times x times x. Absolutely. Any questions about that, or does that make sense?
That makes sense.
Okay, great. Look, we've got an x in the numerator, an x in the denominator. Hey, what's anything divided by itself?
0. Wait, no, not 0.
Not 0. Yeah, 1, right? 1 divided by 1 is 1. 2 divided by 2 is 1. 3 divided by 3 is 3. 10 divided into 10 parts is you're gonna each part's going to be 1. So I think that's how it works. But anyway, so x divided by x is 1. Those essentially cancel out. I am left with just 2 x's in the numerator, and then x times x, right? It's just x twice, basically means x squared. Right? So x to the power of 5 over x to the power of 3 is x squared. Okay. Now, there's a simple operation, which is if you have a like base, which you have right here in x. Okay? A like base. This wouldn't work if it was x to the power of 5 over y to the power of 3. It wouldn't work that way. But here we have a like base in x. Okay?
Okay.
And as long as you have a like base, I can take the exponent from the denominator, bring it up to the numerator, and subtract it.
All right.
All right, that's the operation. Which is probably what you learned, but it never made sense to you, so why would you remember it? And you didn't, which is fine. That's how they teach math, and that's why I hate math. Or I hate it the way that's taught. I like it when it makes sense. But anyway.
All right.
So x to the power of 5 minus 3, 5 minus 3 is 2. Right?
Yeah.
So x to the power of 2, which is what we got right here. Thinking in more concrete terms about what the notation means.
Yeah.
Does that make sense?
Pressure. Yes.
Okay. All right. Now, what if I showed you, now that you know the operation, what if I showed you x to the power of 5 over x to the power of 5? What does that equal?
Would that be just x?
What's anything divided by itself, Caden?
Divided by itself would be just 1.
1. Anything divided by itself is 1, right? And that should make sense, right? Because x power of 5 means x times x times x times x. Maybe there's another x in there. And x power of 5 again, x 5 times. Right? They all cancel out.
Yeah.
It doesn't become 0, it becomes 1.
Yeah.
Okay? Again, or just think, anything divided by itself is 1. Just making that recognition helps.
Right.
Right?
All right.
Or you could do the operation. You've got a like base, which you have in x. Take the exponent from the denominator, bring it up to the numerator, and subtract it. You get x to the power of 5 minus 5, which is x to the power of 0.
Huh. All right. Yeah,
So if you
that makes a lot more sense.
Yeah, so if you see anything raised to the power of 0, basically it means it's being divided by itself.
Okay.
Does that make sense?
Yeah.
All right. Right? And anything to the power of 1, right, just means itself. Right? Divided by 1 maybe, but just itself. But if it's raised to the power of 0, it means it's being divided by itself. Which is always 1. All right. So, let's go back to the expression here in the question, which is this 2 to the power of 0. 2 to the power of 0 is the same as 2 divided by 2, which is 1. So we get 8 to the power of 4 over 1, which is just 8 to the power of 4.
Okay. Yeah,
All right.
that makes a lot more sense now.
Yeah.
Cool.
Okay. All right. So now, you might look at the answer and be like, I don't see 8 to the power of 4, which you don't see.
Yeah.
Okay? Which you don't see. That's okay. We can start eliminating some answer choices. First, I want to eliminate answer choice D. This value cannot be determined from the information given. That is a distractor. They are never going to give you that answer. That's never going to be a true statement. I've seen on a number of practice tests, they're always going to get, on the SAT and ACT, they're always going to give you enough information to solve it. I would never anticipate that. Okay, that's just like, if it's really tough and you don't know how to solve it, a lot of kids are going to choose that, right? There's a difference between not knowing how to solve it and not being able to solve it.
All right.
You know what I'm saying?
Yeah.
All right, and they're just trying to throw you off with that. So I wouldn't even worry about that. Answer choice D is gone.
All right.
Okay, now, there's 2 answer choices that I know with absolute certainty I can eliminate.
Okay. So then,
Which answer choices can I eliminate with absolute certainty?
probably C.
Definitely C,
Yeah, because
right? 8 to the power of 2 is not going to equal 8 to the power of 4,
yeah,
right? I mean, 8 to the power of 2 means 8 times 8,
yeah,
right? And that's just not going to equal 8 times 8 times 2 more 8s, right?
Yeah.
That's crazy. So, answer
Right.
choice C is gone. Yeah. What else can we eliminate with absolute certainty?
Well. Wait. Okay. So that's 2 to the power of 12 and then 4, or 2 to the power of 12 and then 4 to the power of 4. Then it would.
I mean, neither look like 8 to the power of 4, but I know I can get rid of 1 with absolute certainty.
Is that A?
Look, I don't know what 2 to the power of 12 equals.
Yeah.
And I'll be honest, I don't know what 8 to the power of 4 equals. I mean, you could actually, if this was a calculator section question, you could just punch in your calculator and figure it out. Can't do that here.
So yeah.
But I know that 4 times 4, look at answer choice B, 4 times 4 times 4 times 4 is not going to equal 8 times 8 times 8 times 8. It's just not going to happen, man.
I wasn't thinking about it that way.
And you should, right? I mean, that's why I'm trying to teach you here. It's not like 4 multiplied by itself 4 times just cannot possibly eat 8.
Yeah.
Right? A million multiplied by itself 4 times is not going to equal 4. Right? I mean, like they're different numbers being multiplied the same number of times.
Yeah.
Does that make sense? Now, look, I know 8 to the power of 4 doesn't look the same as 2 to the power of 12, but a smaller number multiplied by itself more times could equal a larger number multiplied by itself fewer times. You know what I'm saying?
Yeah.
It's at least a possibility. But I know it can't be B. Any questions about that?
No, that makes sense.
Okay. Don't you see? I mean, like, really, this is like what I'm trying to teach you right now is really just a way of looking at these questions. That is what I'm trying to teach you. It's a way of looking at them. It's interesting, right? And by the way, I think it's a much more interesting way of understanding math than just be like, what is the right operation? Boring. Boring. And annoying.
Yeah, for sure.
But think about, like, we're dealing with actual values. Think about the weight of these values. Think about the meaning of the values. Then it's all just logic.
Yeah.
Okay?
Cool.
Okay. So, I would choose answer choice A, which is the correct answer choice. Okay, that's 2 to the power of 12. I know this. I wrote over the 12 there a little bit previously.
Yeah.
That's what it's saying. It's 2 to the power of 12. Okay? But I can prove it that it's 2 to the power of 12. And let me show you why. All right, I'm going to... I'm going to do this. So we said 8 to the power of 4, right? 8 to the power of 4 is the same as 2 to the power of 12. I can express 8 in terms of 2. Because 8 is the same as 2 to the power of 3. Okay?
Okay.
Does that make sense why?
Yes.
Okay.
Yes. 2 times 2 times 2.
Yeah, 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Okay, so 2 to the power of 3 is the same as 8. So 2 to the power of 3 to the power of 4 is the same as 8 to the power of 4. Those are equivalent expressions. Does that make sense?
Yes.
Okay. Now, I'm guessing this is what you're thinking. You're like, I know I'm supposed to do something with those two exponents, but I forgot what it is. Do I multiply them or do I add them? I can never keep that straight. Is something like that going through your head?
Yes.
Okay, great. All right. Good, because that goes through the head of pretty much, that went through my head as a student, and then it goes through the head of pretty much every other student as well. We can never keep all that straight. This is why I don't coach students to memorize the properties of exponents. It's not super helpful. It's just tough. I mean, some students can do it. Some, boy, and they're all going to be math teachers, and they're going to teach things that just come naturally to them that don't come naturally to anybody else. But anyway, so, boy, this is like math therapy. Going over this. Clearly got some traumatic math class experiences in my childhood. But anyway, so let's think about what that means to raise something to the power of 4. What does it mean to raise something to the power of 4?
So times itself 4 times.
4 times, right? So that means 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3. Does that make sense?
Yeah.
Okay.
And
what's it mean to raise something to the power of 2? Or to the power of 3?
Times itself 3 times.
Times itself 3 times. So that means 2 times 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 2. Do you see where I'm going with this? Times 2 times 2 times 2. There's some ugly 2's right there. How many 2's do I got?
12.
12 2's. So it's 2 to the power of 12.
Yeah. Huh.
Does that make sense?
Yes.
And now you know the operation. What do I do with that 3 and that 4? What do I do?
You basically just break it down.
Well, we can do that. By the way, it's maybe what I recommend to understand it. But what's the operation now? What do I do with that 3 and that 4 right there?
So you take the 2 and so it's in the.
Well, here what I'm saying, like there's a specific operation. When you see a power raised to a power, you're taught to multiply the powers.
Okay.
You're taught to multiply the powers. If you see a power raised to a power, so 2 to the power of 3 to the power of 4, multiply the powers, you get 2 to the power of 12, right? Because 3 times 4 is 12.
Yeah.
That's the operation. Remember I was saying at the beginning, I was like, you're supposed to add them or multiply those exponents, and nobody can remember which one you do, right? That whole deal.
Yeah.
Yeah. That's why you multiply them.
Gotcha.
Does that make sense?
Yes.
And by the way, if I had 2 to the power of 3 times 2 to the power of 4, instead of power raised to a power, if I were multiplying powers, that's when you add the exponents.
Yeah.
So that would be 2 to the power of 7.
Yeah, that makes sense.
Right? Because it's 3 2s and 4 2s. So altogether, that's 7 2s, so 2 to the power of 7.
Gotcha.
But anyway, that's where the operation comes from. But if you understand kind of what the notation means, then you know what to do. Does that make sense?
Yes.
Okay, all right. So I don't think I still have explained why the correct answer is 2 to the power of 12. We're going to get to that. Okay, so let's do that. So we got, where did we leave off at? So we got, so 2, all right. So remember I said that, let's start here. Let's go back to this expression. We're trying to find the value of that expression right there in the question, right?
Yeah.
Okay. So what they want you to do here, the mathematical operation, is they want you to combine those exponents somehow. Just be aware of that. They're always, if they give you variables with exponents, they want you to combine them. Which you can't do here because you don't have a like base, right?
Right.
You don't have a like base. But we can create a like base if I express 8 in terms of 2, right? Which I already did, right? So like 2 to the power of 3 is 8.
Yeah.
Raised to the power of x over 2 to the power of y. Does that make sense so far?
Yes.
It's the same thing. This guy and this guy, the same. Equivalent expressions. Okay. All right, now you know the operation. You know what to do with those exponents right there. What do you do with those exponents?
Multiply.
You multiply them, right? So that's going to give you 2 to the power of 3x, right? 3x is the same as 3 times x, okay, right? Yep. Over 2 to the power of y, all right?
Okay.
And now that we have a like base, we can just combine those exponents, right? We have a like base in 2. We can take the y from the denominator, bring it up to the numerator, and subtract it.
Yeah.
All right? So we get 2 to the power of 3x, it's an ugly 3, 3x minus y. And we're very close to finding the answer here.
Yeah.
Because I know what 3x minus y is. What's 3x minus y? What's 3x minus y?
Oh, man.
Look at the question. Look at the question. What's 3x minus y?
Oh, 12.
12. So it's 2 to the power of 12.
Huh.
That's how they want you to solve it. Which is a very specific operation.
Yeah.
And like never in a million years would I expect most students to be able to figure that out on their own. Never in a million years.
Yeah, that's crazy.
It is crazy, right? I mean, like, you could, with some prep, you could see some more questions like this, be like, oh, they want me to combine the exponents, I got to create a like base, and you can go through all the steps and figure it out. But again, without going through the steps that we went through first to like figure out what exponents mean, none of that would make any sense.
Yeah.
You know what I'm saying? So I say just simplify it and plug in values in place of the variables, and then just make it arithmetic.
Yeah, that's a lot.
It's a lot more. You're a lot more likely to get the right answer, and you don't have to memorize an operation. And there's just nothing weird to mess up if you can do the arithmetic.
Right.
Okay. But with some practice, just be aware that's how they want you to solve it. But whatever.
All right. Good to know.
Yeah. And just be aware too, if you're doing like any prep on your own going through the SAT practice test, the answer explanations they give you are like, I mean, I explained it well, but they're super complicated. They're all like this. They all, show you the algebraic way to do it and all the correct operations. And it's just most students just don't think in those terms, which is okay. It's very few people are going to be math teachers or engineers.
Yeah.
So and that's 100% cool. All right. Any questions before we move on?
No.
Okay. All right. The takeaway again: freaking plug in values in place of the variables. still the takeaway there. But also, when you're dealing with exponents, there's going to be exponents on the SAT. Think in concrete terms. Think about what the notation means, and then you don't have to memorize. Then you don't have to memorize the operations. Nothing. Oh, I love this question so much. Go ahead and read question number 16 for me, please.
All right. If t is greater than 0 and t to the power of 2 minus 4 equals 0, what is the value of t?
Okay, I'm going to stop you real quick. Okay, first of all, notice it's not an equivalent expression question. It's not. So we can't come up with any value for t. We got to work within the limits of the question. T has to be greater than 0 because they say it does.
Yeah.
Okay, does that make sense?
Yes.
Okay, all right. The only exception to that is the equivalent expression questions. So t's got to be greater than 0, and then t squared minus 4 equals 0. What is the value of t? Okay. Before we do any algebra, I'll bet you can look at this logically without doing any fancy operation and figure out what t has to be. Don't do algebra, don't do math, think logically. What is t going to have to be? What number squared minus 4 is going to give you 0?
Oh, so it would just be 2, right?
If you answer 2, you get this one right. That's the answer.
Huh.
That's the answer. It's 2. Because 2 squared is 4. 4 minus 4 is 0. There's your answer.
That's crazy.
This is the SAT. This is an actual SAT question. If you look at it the right way, it's a joke.
Yeah, that's funny. Wow.
Right? But kids are going to complicate it, man. They're going to start like squaring both sides or taking the square root of both sides of the equation. They're just to do some operation. They're going to mess it up. And you don't need to, man. You just don't need to. That's great news.
That's
all right. And this is crazy here. Let me explain something real quick. That pops up in the SAT a lot. If you see you're isolating some variable, solving some variable. In this case, t. It might be x. It might be something else sometime. Okay. Super weird, but it works out this way. Whenever x or t, whatever variable you're solving for, is raised to a power greater than 1. Okay, if it's raised to the power of 2, or if it's raised to the power of 3, or power of 4, power of 5, all the way up to the power of 5. Okay. If it's raised to some power greater than 1, the correct answer, if they're just asking you to isolate and solve for this variable, the correct answer is always a single-digit integer between 0 and 5. Always. Always. It's never bigger. And it's never smaller. It's never negative. I don't know why. But it makes sense, right? Like if x or t were like negative 17 or something like that, like it would just be a much bigger, more complex problem. You'd be dealing with much bigger values, and they're just not going to do something kind of crazy like that. So it's always a single-digit integer between 0 and 5. So just plug in those values. Plug in 0, see if you get a true statement. Plug in a 1, see if you get a true statement. Plug in a 2, or just look at it logically like this. Yeah. You're going to find the right answer. I mean, it may take a while, especially if it's 5. You're like kind of plugging your way through. Okay, But if you see like a bunch of 5s in the question, or a bunch of like multiples of 5, like 10s or 25s, there's a good chance the answer is going to be 5. Right? If you see a bunch of 16s and 32s, there's a good chance the answer can be 4. You know what I'm saying?
Yeah.
So just think, cool. But again, think about it in concrete terms and plug in values. Okay. I've gone through all the practice tests. It's weird. It's crazy. I'm still waiting to see an exception to that. I've not. I've not. I have to ask you to use the quadratic formula or something like that. It's a different story, but like you'll see. And we're going to see more of these questions like this, where it's just it's between 0 and 5. Okay. Cool. Yeah. So don't do the algebra. All right. Let's do the next one. Go and read number 8 for me, please.
For what value of n is n minus 1 plus 1 equal to 0?
Okay, for what value of n is n minus 1 plus 1 equal to 0? What are we solving for here, Caden? Can you tell me?
We're solving for n.
We're solving for n. Yes, we are. We are. Yes, we are. How can we test the answer choices?
Put in a variable. Or we could use the answer choices.
Yeah, those are all potential values. I mean, A, B, and C at least are all potential values for n.
Yeah.
Right? Nice. Plug those into the expression, see if that gives us 0.
Yeah.
And if not, then the answer is D, if none of those work. Right?
Right.
Okay. Now, real quick, before we do that, we got to talk about some of the notation that we see here in this question. You see these funky bars right here in the question?
Yeah.
Right? Do you know what that means, those funky bars?
No.
No. Okay. Those are called absolute value bars or signs or something like that. It's absolute value. Okay? You've seen this before at some point. Okay.
Yeah.
And this is where if you see something like that here, I've got my basic concept cheat sheet. Okay. And where I do go over some of the math concepts you do need to know. Okay. It's a very limited amount of concepts. I mean, it's like 25, 26 concepts or something like that. It's just not that much.
Okay.
But one of those is absolute value. Okay. And I've got that here. It's basic concept J on my rules for mathing. Okay.
Okay.
Do you see that on the rules for mathing? Scroll down to basic concept J.
Yes.
Okay. Go ahead and read basic concept J for us, please.
All right. Calculate what's inside the bars. If it's positive, keep it positive. If it's negative, make it positive.
Okay, so we got the example right here in the basic concept J. It's the absolute value. That's how you read it, by the way, when you see those straight bars, right? They're like straight parentheses. The absolute value of 3 minus 5 equals 2. Okay, so calculate what's inside the bars. What's 3 minus 5, Caden?
3 minus 5 is negative 2.
Negative 2, right? If it's positive, keep it positive. If it's a negative, make it positive. What's negative 2 turn positive?
2.
Just 2, positive 2. So therefore, the absolute value of 3 minus 5 is
2.
2. Does that make sense?
Okay.
So
Yes.
calculate what's inside the bars, and whatever is going to pop out of that, whatever output you're getting from that is going to be positive. So if it's positive, don't mess with it. Leave it positive. If it's negative, just make it positive. That's absolute value. Sometimes absolute value is expressed as like it's the like how far away a number is from 0 on the number line. That's sometimes how it's expressed. So like the absolute value of 7 is 7 because 7 is 7 units from 0 on the number line. But the absolute value of negative 7 is also 7 because negative 7 is also 7 units away from 0 on the number line. Does that make sense?
Okay. Yeah, that makes sense.
Okay, that's kind of the idea. All right. So let's go back to the question.
Okay.
And let's plug these answer choices in for n. That's it.
All right.
Okay, can I see you do that on the whiteboard, please?
Yes.
Great.
So I guess we'll start with A, then if in, so 0 minus 1, and then the bar plus 1. All right. So it would be 0 minus 1, but since it's in that absolute value, it wouldn't be negative 1. It would just be 1.
Yeah, that's just going to be regular 1. So 1.
And then added to 1.
Does that equal 0? Yeah, that's 2, not
Yeah.
0. So answer is A is gone. Let's just leave what you got up there, and then let's just I'll just erase the 0, and we'll plug in a 1.
Oh, all right. So 1 minus 1 is just 0,
0.
plus 1, and then that comes out to 1. So
Comes out to, it's not equal to 0, right? So answer is B
Right.
is gone. What about answer choice C?
so
I'll erase that as well.
right. So then 2 minus 1 is just 1,
Yeah,
and that plus 1 is 2. So
yeah. I mean, you're laughing, right? Why are you laughing?
Yeah.
Why are you laughing? Why are you laughing?
It's so much more simple than I thought.
It's so easy.
Yeah.
It is laughably easy.
Yeah. That was crazy.
And again, these are every single
Wow.
question. This is the first one from all the ones we just did were from I think the last one also was from section 3 of this practice test 1. This is just section 4 of practice test 1. So again, these are all from the same practice test. I'm not just picking the easiest ones from all over. Like I just started with practice test 1, and this strategy applies for all these questions. And if you approach it the right way and look at it with the right eyes, it is laughably easy.
Yeah.
Laughably. And that's the SAT. Don't be intimidated by this thing, man. You're a smart kid. You're a smart kid. Yeah, you struggle with math. Okay, whatever. You're not going to be using algebra at any point in your life after high school. Let me help you out a little bit. Okay, I can say that for most students watching this video. Okay, that's okay. It's okay. This is a safe place. We can admit it. Okay? But you could just use a bunch of logic and common sense and arithmetic, which you will be using arithmetic, I promise you that.
Yeah.
And then this whole test opens up, and you can do most of these.
Yeah.
All right? You got to know math concepts. Like, you got to know what absolute value is. Okay, fine. It's not complicated, is it?
Yeah, once you get that.
Yeah, then it's a breeze. That's all. So know the concepts, study the concepts, practice them. But there's not like a specific operation that you have to. I mean, there is a way to like isolate n with absolute value, and I'll be honest, I don't know how to do it. I don't. All right? I don't care. I know how to solve the problem.
Yeah.
All right. Let's I think we're going to do just 2 more questions. You have time for 2 more?
Yeah.
Okay, let's do 2 more.
Let's do it.
All right, go ahead and read question number 9. Read the introduction also to question number 9 for us, please.
The what?
The introduction to question number 9, like at the top, right? The speed of a
Right.
sound wave.
Okay, the speed of sound wave in the air depends on the air temperature. The formula above shows the relationship between A, the speed of a sound wave, in feet per second, and T, the air temperature, in degrees Fahrenheit. And then, which of the following expresses the air temperature in terms of the speed of a sound wave?
Okay. All right.
All right.
What are we solving for here, Caden?
The air temperature in terms of the speed of a sound wave.
Yes. Do you have any idea what that means or no?
Not really.
Okay, no problem. Take a look at the answer choices. Okay. Notice in all those answer choices, the T, which is the air temperature, by the way, not A. A is the speed. And they tell us that up here, right? A is the speed of the sound wave, and T is the temperature. Okay, so you got to keep that straight. But all those, the T, the temperature, is isolated on the left-hand side of the equation.
Mm-hmm.
Okay? So when they say, which of the following expresses the temperature in terms of the speed? It's just a fancy way of saying isolate the T variable. Get T alone in the equation.
Okay.
Does that make sense?
Yes.
Okay. But then, if you're not sure about like what a question is asking you to solve for, sometimes just look at the answer choices and you can generally kind of figure out, oh, okay, I'm supposed to get T alone. Okay, good. Gotcha.
All right.
All right. They love using that phrasing. Which of the following expresses this variable in terms of all the other variables? It just means isolate that first variable. Okay?
Okay.
Okay, great. All right, so, okay. There's an algebraic way to do this. What a shock. And it's not bad. I mean, if you do any algebra, if you're familiar at all with isolating variables, which most students probably watching this are familiar with it or have been familiar with it at one point in their lives, it's not terrible. Okay, it's not super complicated. You can probably, like 2 or 3 steps, you can probably figure it out. But a lot of students struggle with it. Because it's not intuitive and to everybody. And I'm guessing you would probably struggle with isolating T. Am I right?
Yeah.
Okay. It just, I mean, like, some students just know what to do because they've been drilled enough.
Mm-hmm.
But without that, like, if it's not automatic, it's just not it's not logical what to do. But we can make this concrete again by plugging in values for the variables. Okay. So let's just do that. All right. So I'm going to create a value for T. I'm going to make T equal 1. Notice, by the way, 1s and 0s, man. I mean, it's my instinct.
Yeah.
If it doesn't work, if the smaller number doesn't work, great, plug in a bigger number. But I think so far, like when we're plugging in numbers, I don't think we plugged in anything bigger than, well, I guess we had to plug in 4 into one of them, but I mean, by and large, it's like 1s and 0s.
Yeah.
So, okay.
It starts small.
It makes it really, really, yeah, and then generally you can simplify, really complicated looking expressions just by looking at them when you're plugging in 1s and 0s. Okay. All right, so we're going to make T equal 1, and when T is 1, notice I didn't start with a value for A. I didn't make A equal 1. You know what I'm saying?
Right.
Like if I made A equal 1, then I'd have to solve for T. I'd have to come up with some value for T that somehow gives me an A value of 1, which I don't know what that is, and I don't want to do that. Does that make sense? Like, yes. So when you're plugging in values, plug into the more complicated side of the expression, which is what we've done this whole class. We're always started plugging in values into the more, right? When we plugged in a value for D into the days that lady worked, fixing the phones. We plugged in an A for the age of the kid, right? That's all on the more complicated side of the equation. Same thing here. We plug in the T value. And then to solve for A is real easy. I can look at that without even punching a calculator. We are on the calculator section, by the way, but I can look at that and tell you what the A value is going to be. What's the A value going to be?
It's just going to be, well, it would be 0, right?
No. Do you see the...
No.
We're plugging into that equation right there. When T is 1, what's the A value going to be?
1.
Yeah.
When T's 1, then the A value would just be... So it's just adding that little...
It's just adding that. It's just 1,052 plus 1.08. I mean, if you want to use your calculator, you can. Do you want to? I mean, you can.
Yeah, that's like 1,053.08.
Yeah, that's it. You probably don't need to use the calculator.
That's crazy.
Right? Did you need to use a calculator there or no?
No, it's just adding the...
It's just common sense, right?
Yeah.
Okay.
Crazy.
All right. You guys crazy. You could use common sense in a math class. Isn't that crazy, right? Like, you've probably never done that. And I'm not joking. Like, how sad is that?
Yeah.
Right? Of course you hate math.
Yeah.
Of course.
Man.
Because this whole time you've been doing stuff and like not knowing why and it never making sense.
Yeah. Like
That-
sometimes it works out, sometimes it doesn't.
Yeah, and never knowing why.
Yeah.
And it's super frustrating. But the SAT isn't like that. It's great.
Yeah, who would have thought?
Who would have thought? I really like the SAT because of that.
Yeah.
You can make everything concrete, and it all makes sense if you approach the questions the right way, which I'm teaching you. I'm not a math teacher. Is that obvious that I'm not a math teacher? I'm not a math teacher. Normally, I teach history. I teach history, which is crazy, right? Really, really crazy. And of course, I do test prep evenings and weekends. But I'm not a math teacher, which is why I think I can teach it to people that are also not math teachers.
That's cool.
So anyway, but I think it's my superpower is that I don't teach math. But anyway, all right. So we know when t is 1, a has to be 1053.08. Does that make sense, Caden?
Yes.
Okay, great. So all we got to do is take those values, plug them into the answer choices, and the right answer choice has to give us a true statement when t is 1 and when a is 1053.08. Does that make sense?
Yes.
And you can use your calculator. But I don't think you need to.
Yeah, this is a...
Look at answer choice A. Does that give us a true statement when t is 1 and a is 1053.08?
So when t is 1, then that's just going to be... That would... So no. Wait. Hang on. Now I'm getting lost.
Well, let's write it out. So I'm going to plug in those variables, and I'm testing answer choice A here. So you get 1 equals A, but that's not A. I'm plugging in 1053.08 minus 1052,
It's A's.
right? Over 1.08. Does that give me a true statement? Plug it into your calculator, man. Use it.
So 1053.08 then minus 1052 and then divide. So that would just be 1.
Yeah. Right. So we got a true statement, right, on the right-hand side?
Yeah.
Okay. Good.
All right.
All right, so that works. Let's leave A. What about B? Do I get a true statement?
Okay, so it's A plus that. So plus this time.
Mm-hmm.
So
Is that going to equal 1, man?
no.
No, dude. I don't even have to plug that into the calculator.
Yeah.
I don't know what that is. I don't know what the answer is. I don't care. It's not going to equal 1.
Yeah, if it doesn't.
I'm getting like 2,000 something or other divided by something close to 1. It's not going to give me 1. It's going to be something close to 2,000. Right? Does that make sense?
Yeah.
And again, the beauty of estimating like this is like you don't even have to calculate everything. They're not asking you to solve for that. It's just a question, is that a true statement? Does that equal 1 when t is 1 and a is 1053.08? Does that give us a true statement? And the answer is no.
Yeah, that's cool.
Okay, so B is gone.
All right.
What about answer choice C?
So C, that's...
Don't even worry about calculating. Just look at it.
Yeah, so then A... no.
Why do I know that can't be a true statement?
Because it's subtracting a higher number.
Subtracting a bigger number, yeah. So you're going to get a negative number in the numerator. Now, if the 1.08 and the denominator was negative, maybe, but that's going to give me a negative number. And 1 is not negative. Right. Positive 1 is not negative. What a shock. So, answer is C is gone. What about D? Just look at it, man.
D,
just look at it.
Yeah, you
Come
have
on.
to divide here.
Come on. Get out of here.
Yeah, so A.
It's A.
Huh.
Any questions?
That was fun. No, that's crazy. I like that.
Yeah. So many of these questions, man. All over
so
these practice
it's
tests.
It's so complicated until you see it a certain way.
Mm-hmm. So I'm trying to teach you. You just got to look with the right eyes. See it with the right eyes. That's the trick.
Right.
Okay. Now, I'm not saying it's super easy to set this up like, I mean, what if you plugged in a 0 for t? You know, you wouldn't be able to eliminate. I think you could eliminate. Actually, you could eliminate 2 answer choices if you plugged in 0 for t. Right? Because then A would still be 1052. Right? Mm-hmm. If t was 0. Does that make sense?
Yes.
Yeah. So you're not adding anything. So A would be 1052, and then you could eliminate A, which would be negative.
Right.
Or that would be, and that would be like really that would be like negative 1000. You know. Oh no! I lied. Wait. T would be. No, I lied. No, that would be. I'm sorry. I was doing it the other way around. A would be no, because A is still the correct answer, right? A is 1052, right. So you do get 0 for T. Does that make sense or no?
Yes.
Yeah?
Yeah,
Okay.
you're just a different value.
Yeah. Sorry, I was plugging a 0 for A and not 1052. But B wouldn't work. That's still too big. It doesn't give you 0 for T. C would work. No, wait. Yes, C would work. C would give you 0. But D wouldn't. So at the very least, you got A and C. If you're just guessing there, it's a 50-50 shot. But that's why I get, then plug in another value.
Yeah.
Okay, oh no, and you see one works.
That's cool.
Okay, does that make sense?
Yes.
Okay. All right, let's do one more. All right, so this piggybacks on number 9. So just read number 10, because we've already read the introduction to this question.
All right. At which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second?
Okay. Mm-hmm. What are we solving for here, Caden?
What following air temperature will the speed of a sound wave be closest to 1,000 feet per second? So,
yeah, which air temperature will the speed of a sound wave be closest to 1,000 feet per second? How could we solve this by testing the answer choices?
We would refer to the question 9 thing. So sound one.
We could use question 9, or we could just use the equation right here. I mean, either whatever's easier. What do you think is easier, using the equation of the question, or using?
Probably the question.
I think the equation of the question is usually how I solve this. I mean, technically, you could plug in like 1,000 for A into answer choice A and see what the temperature is. You could do that. But yeah, just still plug in values. Or what I'd probably recommend is just plug in the temperature in for T into that equation, right? You know what I'm saying?
Yeah.
And then see which A value is closest to 1,000.
All right.
Does that make sense?
Yeah.
Hey, it's just arithmetic. You're not doing any algebra here. You know what I'm saying?
Yeah, I see.
Okay.
All right, so
show me what that would look like.
Okay, so then it would just be like drawing it out with so A equals 1,052 plus. Let me get more space here. 108 and then T. So I guess work our way down. So 46. Like that.
Yeah, it looks good. All right. This is a calculator section question. Go to use a calculator.
All right. Okay. So parentheses comes first. 108 is 46. Or negative. Wait, no, times negative 46.
Yeah, you got to do that. Once again, it's PEMDAS, right? We got to do that multiplication first.
Right. Okay, I think my calculator skills are needing
That's all right. That's all right. That's why you're doing this, man. Make sure, by the way, whatever calculator you're using on the SAT, whatever one you plan to use the SAT, is the one you use in your prep too.
Okay.
You don't want to bust out a really complicated graphing calculator that you've never used before when you take the test. Yeah.
Right. Okay. So I would have to start with that, with the right side, because it has the multiplication.
Mm-hmm. Yep. Yeah. So what is that? What's 108 times negative 46?
Negative 4,968.
That feels off. That feels off. Yeah. Hold on. Let me check.
I don't know what I'm doing wrong.
That's right. It's just 108 times. I'm using the old iPhone calculator here. 108 times 46 is. Oh no, that's right. That's right. What did?
And then.
Oh, 1.08. That's the issue. Ha ha ha. We lost the decimal. We lost the decimal.
My bad.
Yeah. That's funny because I
Alright,
was subconsciously, I was plugging in 1.08. And anyway, okay, so try that again.
Okay, negative 49.68. That's what I got.
Negative 49.68?
Yes.
That feels a lot better, doesn't it?
Yes.
Okay, so it's 1,052 minus 49.68. What do we get?
1,101.68. Unless I switch.
Yeah, I think I got some. Let me double check one. Minus 49.68 equals. Yeah, I got 1,002.32.
I must have
Twice. Just sometimes you just punch the wrong button. It's no problem.
Yeah.
So yeah, I got to brush up on the calculator skills, but that's right. That's easy. Okay. So I got 1,002.32, which is close, right?
Yeah.
That's for answer choice A. Let's try answer choice B. Let's see what we get.
All right.
So we're just plugging in negative 48.
So that comes out to negative 51.84. And then so that comes out to, when you add those up, then that's 1,000.16.
Ooh, I like that. It's closer.
Yeah, that's close.
Okay. So A is gone. Because
Right.
B is closer. Let's try C. Plug in negative 49.
Okay. 0.08 times 48. Negative 51.84. And then add that to 1,000. Wait.
You got 51.84 again?
I must have misclicked or something.
Yeah, because I got the same as B, and that shouldn't be right. Double check. It's 1.08 times.
I must have done 40.
That's right.
Again. Yeah, because it's 52.92.
That's what I got too. 52.92. So then 52.
So that's 999.0.
Okay, it's close.
Not
999.08. Which one's closer, B or C?
B.
B is closer, so C's gone. Do we need to try D?
No.
No, right? Because that's going to be even more negative. So it's going to be smaller than C.
Right.
So
then it has to be B.
Just logically, we know it has to be B, which it is. We could,
Huh. That's cool.
Any questions?
No.
How much algebra have we done today?
0.
0. No algebra's done
Yeah. Huh.
on this test.
Who would have thought?
There's like one question on that section 3 that we were working on practice test 1 that you have to do the algebra on. One question.
Out of
20. Out of 20, yeah. I mean, out of 20 on section 3. And there's maybe 2 or 3 questions on that total on all the practice test 1 where you have to do some algebra. It might just be 2. And I know of only one that I can think of at the moment. I'm guessing it's probably 2. You just don't have to do algebra on this test, not much. You just don't have to.
That's awesome.
It is awesome. It's great. Okay?
Yeah.
Now, there's other concepts too. There's probability, and there's some statistics, and like some things. I mean, and I do cover that in a level 2 math class as well. The more specific concepts, but the vast majority of the questions just involve this sort of strategy and this sort of logical thinking.
Right.
The vast, well, I would say the vast majority. Again, it's between a third and half of the questions. The strategy applies. But of all of the concepts they're testing you on, it's just logic and estimation. Okay.
Cool.
All right. Any questions before we wrap it up? Because I think we're going to wrap it up with that question.
I don't think so.
No. Okay. So for homework, I'm going to send you a link to a document with some new questions you've not seen yet that all involve plugging in values in place of the variables.
All right.
Okay. It's not a lot. It's like, I don't know, 6 or 7 questions, something like that. But I also want you, and everybody watching the recording as well, if you have access to the class, I want you to try answering the questions on your own using the strategies I teach in the class. I think it's very important. Same thing for you, Caden. I want you to redo the questions. I know you solved them once with me,
Right.
But I want you to redo it because you've got to practice looking at the questions this way. You've got to practice solving them this way and thinking in these terms.
Okay.
Okay, and the repetition is important. I mean, if you want to like learn a piano piece, like you play that piece again and again and again until it's automatic, and you have to approach the questions this way because you're like this is just not even not even close to automatic. You've been approaching math a certain way for almost all your life, which is a very frustrating and annoying way.
Yeah, for sure.
Right. And you've just got to practice. You got to put in the reps. Okay.
All right.
So practice these questions on your own. Try the new ones. If you can't solve any of them on your own, no problem. That's right. We're going to go over every single one of those at the beginning of the next class.
Cool.
Okay? So don't feel like you have to understand everything, but I do want you to practice. I'm going to send you links to the recording as well. So like if you forget how to solve one of the questions that we've gone over, I want you to just review the recording, right? And then you can solve it on your own. This is huge. Like just by watching these videos, and this is for anybody watching the recording, just watching the videos is probably not going to be enough to get you a score increase. I can almost guarantee. I've had a couple students that have gotten really, really lucky. Really lucky, okay, but and that's probably not going to be you, just based on the odds. You know who you are. Do the work. You've got to practice, and but if you can do that, you don't need to get to get a good score increase, like a 100-point increase on the SAT math. Depending on the practice test, I mean that could be 10 questions potentially that you weren't getting right before that you're getting right now. Maybe 10 to 12 questions. But up to 10 on some tests. Getting 10 more right will give you a 100-point increase on some tests. So you don't have to go for perfection. And then most students would kill for a 100-point increase on the math. That's just on one section, right? Not a total increase. All you got to do is get 10 more right.
Yeah.
So we're not going for perfection. It's about getting the ones you should be getting if you think about them the right way. That's the name of the game.
Okay.
Okay. So.
Cool.
And there's going to be some high level stuff that I coach students. There's some questions I'm like, when you see one like this, just skip it. There's something called the discriminant they test you on. It's a complex quadratic operation. If you see that, just recognize what it is and just skip it. If there's an equation with circle question, a lot of them are super complicated. Just skip it. If it's a quadratic formula, it's going to take a long time unless you're really, really, really comfortable with it. Most students I coach just skip it. That's fine. Focus on the ones you should be getting, like these questions, if you think about them the right way. All right?
Yeah.
All right. If you've got questions anytime between now and the next time I see you, Caden, feel free to reach out to me. But it's been an absolute pleasure. I look forward to working on the next classes with you as well. Okay?
Yeah.
All right. Thank you, Caden. Take care.
Thank you.
All right. Bye.
Bye.